welcome to this new presentation of the Plant-Based Processing webinar series by SPX Flow. This presentation is about clean-in-place systems, which are usually described as the heart of the food and beverage process equipment. My name is Thomas Leroy, and I am the Global Head of Innovation Centers for the SPX Flow Nutritional and Health portfolio, and I will be your technical host for this webinar. A little about myself. I have a long background in the food and beverage industry, leading trials, and have collaborated on many plant-based projects during my time at SPX Flow. It is my goal to cover all plant-based opportunities and discuss to manufacturers about new recipes and relevant processes they need, as shown here with fully integrated processing lines. The best ways to conserve water and energy, optimize efficiency, are the heart of our concerns. CIP systems take their place here. And more globally at SPX Flow, our purpose is to improve the world through innovative and sustainable solutions. We'll strive to follow this purpose during today's presentation by addressing the challenges in plant-based processing, the basics of clean-in-place systems, key cleaning parameters focusing on sustainability aspects, monitoring of clean-in-place systems tailored to customer needs, the importance of integrating proper cleaning practices, and a final question and answers session. Just a comment before we get started. As an audience member, you will not have audio or video capability. Please use the Q&A feature to submit any questions throughout the presentation, and I will answer as many as I can at the end. If we do not have time to answer them all, my contact information will be provided during the Q&A session. So let's get started with a discussion on sustainable clean-in-place systems within plant-based processing lines. As an example, we can consider the overall process for oat-based beverages, starting from growth. There are several processing steps, and every single equipment must be cleaned in an efficient way to maintain optimal production performance while ensuring proper hygiene of the installation and product safety. Cleaning concerns product transfer lines, tanks and mixers, heat exchangers, valve clusters, and all the others. And while we are here, I want to highlight that we at SPX Flow are original equipment manufacturers that can cover most of the processing steps described in the previous webinars. For some specific equipment that is not part of our portfolio, we have the right partners to supply a fully integrated line to meet your plant-based needs. We also have specialized testing centers all over the world to support you design, develop, perfect your manufacturing processes. But how is cleaning an integral part of the challenges in plant-based processing? If we focus on plant-based beverages, also called milk alternative beverages, the purpose is to be as close as possible to cow's milk in appearance, taste, composition, consistency. It is the same for cheese analogs or meat analogs. But if there is one cow's milk, or let's say more broadly, one animal's milk, there is a diversity of plant-based raw materials, all different in composition, especially sugars profile, protein, and fiber content. Processing lines must be adapted to all of them, which may cause high manufacturing costs. The diversity of raw materials increases the complexity in terms of regulations, allergen management, cleanability, sustainability, as these processes use a lot of water and energy. SPX Flow is here to support you on all these challenges with our know-how, with our people who are having expertise with tackling those challenges. As said previously, the central clean-in-place systems let's call it CIP systems, is the heart of the food and beverage plant. CIP is a set of automated activities conduct to properly clean all or part of a process system as it sits in place without removing or disassembling piping or equipment to accommodate the cleaning. A CIP system is basically made of tanks for cleaning solutions, piping with pumps, valves, heaters, sensors. But let's go into details about CIP system, starting with some basics. Cleaning is inevitable in plant-based and other food and beverage industries, as it helps to remove residual product or biofilm from processing lines and equipment using turbulent cleaning fluids. It also guarantees proper hygiene of the processing lines by preventing contamination, ensuring food safety and product quality, while maintaining overall optimal production performance. Clean in place applies to closed systems, tanks, piping, and associated equipment as previously listed. The cleaning solutions are directly applied and collected in a controlled way. The equipment should be cleanable without the need to be disassembled, and should be designed to be properly cleaned, meaning that all areas must be accessible to detergents at defined parameters. In food and beverage industries, it is obvious that cleaning is a production inconvenience as it costs money and energy and consumes production time. So CIP system should ensure proper cleaning in minimizing time, energy, water, and chemical consumptions. Said differently, cleaning efficiency is determined in terms of cleaning results and savings achieved. Energy and water saved, time saved. SPX Flow owns state-of-the-art technology in designing and installing efficient cleaning place systems to reach the most demanding cleaning performances, ranging from small standard solutions to large tailored CIP systems able to clean several items at the same time. We can see here a system with 10 cleaning lines. As cleaning is achieved through a combination of chemical effect by the action of detergents at a given temperature for a given time, and mechanical effect by the force of the fluid removing dirt from the surface. The combination is well known by the acronym TACT. As these parameters are continuously controlled by efficient sensors installed on the piping going to and returning from the equipment to be cleaned, so to guarantee supply of the detergent or rinsing water at the right temperature, flow, concentration, and time. To have efficient contact of the CIP solutions on the surface of the equipment, it is important to have right pumping and heating devices plus efficient valves with control unit to prevent any leakage. SPX Flow can offer you here the best equipment possible. In terms of concentration, new types of photometry sensors have been developed recently based on UV absorbance or fluorescence to optimize rinsing water use. As traditionally, the CIP process involves several steps, including pre-rinsing to remove most of remaining dirt adhering to the wall. Pre-rinsing is a very important step in the CIP process to make the rest of the cleaning cycle predictable and repeatable. Then detergents are used to remove adherent dirt and minerals with one or more detergent solutions. First, alkaline solutions in the range of 75-80 degrees, then acid solutions at 55-60 degrees. And subsequent rinsing phases with fresh water are necessary to rinse out remaining dirt and detergent residues. As final sanitation with hot water or steam sterilization can be required before production and can be integrated as final step of CIP sequence. All these steps are defined according to CIP recipes and automatically controlled. The amount and quality of water used during rinsing phases is critical to sustainability. As the new kind of photometry sensors previously mentioned are able to analyze suspended and solved materials and allow advanced water quality measurement technology, contributing to overall cleaning efficiency. But the most efficient ways to save rinsing water is to reduce the residual quantity of products into the pipes at the end of the production by using scrapping systems, also known as pigging systems. At SPX Flow, these systems are called rapid recovery systems, as they allow to recover in a rapid and efficient way the residual product adhering to the pipes, and so reduce product losses and make the pre-rinsing more efficient. As a consequence, rinsing water and chemicals usage is significantly reduced. It is the same for overall cleaning time and changeover time, increasing uptime for production. SPX Flow recently launched an aseptic design of rapid recovery systems for your most sensitive and valuable products. Please visit our website for more details and information on this new equipment. As mentioned, the cleaning steps are automatically controlled according to CIP recipes, depending on the product, the duration of use for the equipment to be cleaned, and also the use of detergent used. You can see here an example of CIP sequence with temperature, time, concentration for detergents, cleaning frequency. We are not going to read through the table, but just mention that we generally make the difference between raw product, so prior heat treatment, and pasteurized product. Heat treatment devices are also considered separately in terms of cleaning requirements with more severe cleaning conditions. Monitoring CIP is simplified with a tool called CIP Expert at SPX Flow. CIP Expert is a proprietary software developed by SPX Flow to control the cleaning sequences. CIP Expert is an extension of Factory Expert, an automation MES system supporting the entire plant tailored to customer needs. CIP Expert allows the reliable storage and presentation of CIP sequences and allows the analysis of all cleaning events so to optimize CIP sequences. But before defining CIP sequences, it is essential to ask the right questions before designing a CIP system so to have the best optimized cleaning possible. Listing the equipment to be cleaned is the first step to design the proper size and location of the CIP systems without forgetting the future expansion of the plant. It is also very important to list the different products made in the plant, as the segregation of the equipment to be cleaned is crucial, so to prevent from contamination risk through the CIP system. In many cases, raw product circuits are cleaned separately from pasteurized product with different CIP tanks or different CIP systems for the biggest plants. Segregations of processing equipment is key for the plant making both dairy and non-dairy products due to the major constraint of it. Do it again. Segregation of processing equipment is key for the plants making both dairy and non-dairy products due to the major constraint of allergen management and cross-contamination risks. This is also the case in plant-based factories processing different raw materials. This highlights the central place of cleaning at the heart of all considerations within plant-based processing. Are listed here some of the critical topics around consumer safety when it comes about plant-based products. I would like to highlight the microbial challenges in plant-based foods, as microbes are integral part of plant matrices that mostly grow in the ground. The variety of microbes present in plant-based raw materials is high, and spore-forming bacteria or fungi are the major safety risks. Knowledge of allergen management is also key, and particular attention must be paid to closing, storing, cleaning, and allergen testing from critical process points, with some testing on surfaces or drinking water. In most cases, a proper cleaning ensures food safety, product quality, compliance, and consumer trust. SPX Flow has a significant experience in these major topics that revolve around cleaning in plant-based processing. We will be happy to have further discussion with you on these topics. This was an introduction to cleaning place systems in plant-based processing to give you an idea of SPX Flow offering in this area. As you may be aware, my colleagues are sharing a full series of sustainable plant-based processing webinars representing how SPX Flow can support you in every step of your processes. In the communication material you have received, you should find links to past events and the ability to register for the next and last webinar. This ends today's presentation, and I will now begin our questions and answer session. If you have not already submitted a question about the content I shared today, please take time to do so now, and I will enjoy hearing from you. Just a quick note, after we complete the webinar, all participants will receive a copy of this presentation and the ability to ask a question privately. Thank you for your time, and please give me a moment while I'll pull up your questions. So I can see that you have submitted some interesting questions. So I will try to answer some of them in the 5-6 minutes we have left. But if we do not have time to reply all of them, do not hesitate to send the question to the link you will receive together with webinar material, and I will reply to this question privately. So let's start with the first question. The first question is it possible to have the same CIP system within the same dairy and plant-based factory? Yes, the reply yes. So some of our dairy customers decided to diversify their production by manufacturing additional plant-based products as desserts or plant-based fermented products on top of their dairy products. And in some cases, the same equipment can be used for both types of products, including the CIP system, using some specific and rigorous cleaning procedures developed by the customer. So this procedure could be, for instance, one dedicated caustic tank for or dedicated to cleaning the plant-based equipment. So two different cleaning tanks, one for dairy, one for plant-based. Others used to run two consecutive complete CIP cycles when they move from dairy to plant-based products or reverse. Whatever it is the customer's responsibility to define
relevant cleaning procedures and to do the relevant cleaning test to confirm the efficiency of the cleaning. Another question is, what is the capacity range in CIP systems at SPX flow? The right is the range. The range is wide. Sorry. From the smallest skidded solution, so starting with one tank, could be from 500 liters up to 1,000 liters with one line, so for the smallest one, up to a large CIP station with 4 or 5 tanks, each of them by 20 or 25 cubic meter, and up to 10 lines, as we have just seen during the presentation. But in general, we can say that SPX Flow can design the customized CIP station, CIP system, taking into account the expectation, the specific expectation from the customers. So it could be, for instance, one tank for hot water used for sanitation at the end of the cleaning process. Could be also one disinfectant tank, or the possibility to dose disinfectant inline. I would say also could be the possibility for self-cleaning of the CIP tanks. So from time to time, the tank can be cleaned automatically. It's also a part of a customization on the CIP station. And also the installation of specific sensors. So especially the new kind of photometry sensors we have mentioned during the presentation that can be used for better management of water for water preservation. One interesting question is about the main constraints in terms of cleaning with plant-based raw materials. So I understand the differences with dairy cleaning with dairy products. So during the presentation, we have mentioned the microbial challenges and food safety risk due to the high microbe content. Could be in the plant-based raw material, so could be spore-forming bacteria or fungi, so that present a risk for the food safety. Also, we mentioned the allergen management, but we can also mention that the high content of fibers in plant-based raw materials makes cleaning particularly difficult. And some specific solution can then have to be put in place to improve the cleaning efficiency of the equipment. For instance, if we consider the centrifugal decanter that is used for the separation of insoluble fibers at high temperature, around 80–85 degrees C. So this is one of the equipment that requires specific cleaning. And even if we do an effective pre-rinsing, a considerable amount of organic matter, fibers, is found in the caustic solution and can degrade the effectiveness for subsequent cleanings. So in some cases, it is relevant to propose to have a second tank for caustic with a smaller capacity, but dedicated to cleaning the decanter and its surroundings. Okay. I see that maybe we are now close to the end of the webinar, so maybe some other question, but yeah, again, I will consider all the questions raised during the webinar, and I will collect all necessary information to reply as best as I can personally. So thank you for joining and for your participation. We appreciate the time you spend with us, and look forward to connecting with you again soon. Thank you. Goodbye.